Now that we've conquered A, B, and C, let's go on to D, E, F. So, change in entropy deals with dispersion of matter. When we go back up to our reaction, we have a gas and a gas as reactants. And if the reaction goes forward, we get a solid. This gas condenses. That's the opposite of dispersion. So answering our question, state whether the entropy change, delta S, is positive, negative, or zero. Very, very important. Answer the question directly. Make that your very, very first statement. I've talked to these poor graders who go through thousands and thousands of these FRQs, 160,000 total. And they say one of the disheartening things about grading is people will give some great explanations, but they won't answer the question directly. And if you don't answer the question directly, they can't give the point. So answer the question, answer the question, answer the question. Now, let's give the reason. The number of gas molecules decreases as the reaction makes products. That would be explaining the particulate level. We're saying fewer molecules of gas. You could say as a solid where the particles are locked together. That would work too. Thus, a decrease in entropy, the dispersion of matter. You don't have to write any more than that. Don't write a paragraph. The more you write, the more likely something can be said that's wrong. And if you say one thing wrong in your statement, everything is lost. It's called shooting yourself in the foot. Entropy is really a very complex topic, and you can watch hours of videos explaining the intricacies of it and the exact definition of it. But rather than going down that rabbit hole, for AP, we're going to use the AP definition, which is sort of condensed, it's not exact, but it works. The definition that AP gives is entropy increases when matter becomes more dispersed, for example, a phase change, or entropy increases when energy is dispersed. So that's all we'll deal with. In terms of examples, here is a table from my outline. You can see some pretty obvious dispersions here of matter. Solid going to liquid, liquid going to vapor. One of the unusual things is very often when you dissolve a solute in a solvent, you'd expect that it always would increase entropy because you see the solute is dispersed. But when that happens and ions are involved and intermolecular forces come into play, water molecules, which are pretty random in a solution, may organize around these ions, and you can actually have a decrease in dispersion because the water molecules are rearranged. In some cases, you can have a decrease in entropy with the solution. Another one, of course, is increasing temperature. You can see with the Maxwell-Boltzmann curve that you have a greater range of molecules at different speeds. The increase in number of moles of particles is pretty obvious. The last one that's in the bottom right is the mixing of particles and atoms forming molecules. The explanation is that you've got separate molecules, A and B, so they're separated, but when they come together to make molecules and the number of molecules doesn't change, in effect you've mixed them together. So that's the last example that you'd have to worry about in AP chemistry for increases in entropy. Next, here we got E. We only have E and F left. State whether the change in enthalpy, which is our delta H, for the reaction is positive, negative, or zero. Justify your answer. Don't forget, you've got to answer the question. We're going to say positive, negative, or zero. Now here's my answer, which is an equation. We found that the delta G was negative, which means the reaction produces products more than reactants. If we start with 1 molar of everything, we end up getting more products. We found that the delta S was negative. In D, temperature, of course, is positive in Kelvin. So what's happening is that the delta S is going to produce a positive value and stop the reaction. So the change in energy, change in stored energy, the change in enthalpy has to be negative to overcome the hindrance of the change in entropy. You can put that pretty simply. Delta G is negative, thermodynamically favored reaction. S is negative, not thermodynamically favored. Because of this, the only way delta G can be negative, oh wait a second, I have to answer the question. For delta G to be negative, delta H must be negative. Did I answer the question? Yes, negative right here. And this explains it. You can use the equation. You didn't have to write all of this. I could have just written down delta H to be negative, delta H must be negative. See, answer the question, justified. Last part. This is where you hope you've spent a little bit less than 24 minutes in answering this. After a certain period of time, 1 mole of chlorine is added to the mixture in the flask. Does the mass of the U3O8 solid, here's our solid, increase, decrease, or remain the same? We know that the reaction quotient is the result of these three things. First of all, here's the answer that I gave. The mass of U3O8 will decrease. I answered the question. But, of course, why? Let me give the explanation why. With the addition of the Cl2, okay, we've increased the Cl2. Our reaction quotient is larger than K. This number gets bigger, and it's not equal to the constant that it should be at equilibrium. So, therefore, the reaction has got to get rid of some of this chlorine and consume some of the U3O8. Even though U3O8 isn't in the equation, it has to be used up, because if the chlorine is decreased, it's got to take the U3O8, the triuranium octaoxide, with it. So look at the equation. You could have used Le Chatelier there, but I advise using Q. I'm quite sure you get this marked correctly, but if you use Le Chatelier in a later unit where we deal with electrochemistry, you can't use it. But this is the ideal answer. Even though Le Chatelier, we applied the stress, the reaction moves to remove the stress. To do that, the chlorine has to react with the U3O8 to make these products. There we go. A FRQ that covers, so much. And, of course, it shows that you know so much. And that's why they ask these FRQs. You want to be able to show off all your knowledge when you take the AP exam.